chemical reactions of amines. Alkylation reaction. Alkylation of amines means reaction of amines with the alkyl halide. In this reaction, the hydrogen atom of the amino group will be replaced by alkyl group RNH2. When react with an alkyl halide, there involves nucleophilic substitution reaction. Alkyl halide, this halogen atom will be substituted by the nucleophile primary amine. Primary amine is a nucleophile. This RNH group substitute the halogen here. Alkyl halogen bond breaks and this halogen atom will be substituted by RNH group. So we get the compound RNHR, that is a secondary amine. A primary amine, when react with an alkyl halide, we get a secondary amine. Or this can also be considered as alkylation of amine. In amine, hydrogen atom of amine replaced by alkyl group. One hydrogen replaced by an alkyl group, that is secondary amine. Secondary amine on further alkylation, on reaction with a second molecule of alkyl halide, we get tertiary amine. This hydrogen atom of the secondary amine replaced by another alkyl group. We get tertiary amine, R3N. When tertiary amine further react with another alkyl halide molecule, we get quaternary ammonium salt, R4N plus X minus. So primary amine on alkylation gives secondary, which gives tertiary, which on further reaction with alkyl halide gives quaternary ammonium salt. So this reaction can be used for converting primary amines to secondary or secondary amines to tertiary. For example, ethylamine. This is ethylamine or ethaneamine. This ethaneamine, we can convert this ethaneamine, this is primary, into N-ethylethanamine or N-diethylethanamine can be prepared from it by alkylation. We can introduce any alkyl group into this amine, replacing the hydrogen atom. So when we treat this compound with which alkyl halide, which alkyl group we need to introduce into the amine. For example, if we need to introduce methyl group, N-methyl ethaneamine, we need to add CH3Cl. Methyl chloride. Methyl chloride when react, what happens? Here CH3Cl bond breaks and this CH3 group would substitute the hydrogen atom of amine. This halogen atom of alkyl halide is substituted by this C2H5NH nucleophile. Anyway, the reaction, the product will be C2H5NHCH3 plus HCl. HCl will be eliminated. That is N-methyl ethaneamine can be prepared, secondary amine. If you want to prepare N-dimethylamine, what to do? Again reaction with one more CH3Cl will give C2H5NCH3 twice, CH3CH3. N-dimethyl ethaneamine, that is tertiary. Similarly, aromatic primary amines can be converted to secondary and tertiary amine by reacting with the alkylation, suitable alkyl halide. If you want to prepare N-ethyl aniline, we need to use ethyl halide, C2H5, let it be iodide, C2H5 iodide. The C2H5 group will be replace the hydrogen atom of aniline and we get the compound as NH, one hydrogen atom of aniline replaced by C2H5 group. N-ethyl aniline, secondary amine. Similarly, if you want to prepare N-diethylamine, we need to use one more ethyl iodide. One more ethyl iodide molecule if you use, we get this hydrogen also replaced by C2H5 group. That means if you use two C2H5I molecule, what happens? This hydrogen also replaced by C2H5 group. That is N-diethyl benzeneamine or aniline. So this can be used for converting an amine into a primary amine into secondary or secondary into tertiary. This is alkylation of amine. Next one, acylation of amine. Acylation means reaction of amines with acid chloride or anhydrides or esters. Here the reaction is hydrogen atom of the amine. Hydrogen atom of the amine will be replaced by an acid acyl group. That is this CH3CO group. This group will be introduced into the amino group. That is the reaction mechanism goes. The reaction takes place in the presence of pyridine, a base. C2H5NH2 ethylamine when react with CH3COCl. This is ethanoyl chloride or acyl chloride. What happens? This CO group is polar. So this bond pair of electron will be taken by oxygen, making oxygen negative and carbon positive. This C2H5NH group acts as the nucleophile. This is also nucleophilic substitution reaction. This nitrogen atom, lone pair electron present on this nitrogen atom will be donated to this positive carbon atom and form a bond. This NH nitrogen is bonded to this carbon atom and we get an intermediate C2H5 NH H. This nitrogen become positive. It form a bond to this carbonyl carbon C, single bond O minus CH3. The CH3 group I showed above, Cl. This is an intermediate, highly unstable. What happened here? This oxygen donate a pair of electrons. This carbon chlorine bond breaks and removes chlorine as chloride ion, and this oxygen gives one of the lone pair electron on this oxygen enter into form a double bond here, and this nitrogen, since it carry a positive charge, take the electron pair shared with one of the hydrogen atom and remove this hydrogen as a proton, and what do we get the product as C2H5 NH C double bond O CH3, eliminating H plus and Cl minus, that is eliminating a molecule of hydrogen chloride. The reaction takes place in the presence of a base pyridine, because this pyridine will neutralize the hydrochloric acid formed during the reaction and shift the equilibrium towards right hand side. So the mechanism, without writing the intermediate, we can easily give the product as this. For the same reaction, C2H5NH2 plus ethanoyl chloride CH3COCl. Here the reaction is interaction of this carbon chlorine bond breaks and this NH bond break and eliminate a molecule of HCl. A molecule of HCl will be eliminated and these two are bonded. C2H5 NHCOCH3. That is the final product. C2H5 NHCOCH3. This is amide. NHCO bond is called amide. This is an amide containing two carbon atom. CH3 carbon, then CO carbon. Two carbon containing amide. It is called ethanamide. Ethanamide. This ethanamide contains an ethyl group on the nitrogen atom. Hence it is called N-ethyl. This is N-ethyl ethanamide. So acylation of amines gives amide. Now next another example, the secondary amine. This is a secondary amine, NN diethylamine or N-ethyl ethylamine. When it reacts with, instead of acid chloride, it reacts with anhydride, acid anhydride, ethanoic anhydride or acetic anhydride. Here also the reaction here eliminates a molecule of this bond breaks here and elimination of a molecule of acetic acid takes place here. A molecule of acetic acid will be eliminated. CH3COH will be eliminated and this nitrogen is bonded to this CO carbon. So we get the product as C2H5 C2H5. This nitrogen bonded to this carbonyl carbon, C double bond O CH3. This is also ethanamide. In this ethanamide, this is again two carbon containing amide, ethanamide. On ethanamide, nitrogen contain two ethyl groups. So this is N, N diethyl ethanamide. Aromatic amines also undergo acylation reaction. Aromatic amine, this is aniline. When react with acetic anhydride, here also elimination of a molecule of water with the hydrogen of the amino group and CH3COO group of the acetic anhydride or ethanoic anhydride eliminates a molecule of acetic acid, and we get the product as C6H5NHCOCH3. This is also ethanamide. Ethanamide contain a phenyl group on nitrogen atom. So this is N-phenyl ethanamide. N-phenyl ethanamide. This is also known as acetanilide. N-phenyl ethanamide is also called acetanilide. Benzoylation reaction. Reaction of amine with benzoyl chloride is called benzoylation reaction. That is an amine, methane amine when react with benzoyl chloride. This compound C6H5CO group, this group is called benzoyl chloride. Here also the same reaction, HCl molecule eliminate, and this group CH3NH bonded to CO C6H5. This compound is called benzamide. This is benzamide. In benzamide, nitrogen contain a methyl group. So this is N-methyl benzamide. So acylation reaction is again nucleophilic substitution reaction. Hydrogen atom of amines are replaced by an acyl group, CH3CO group, or halogen atom of acid chlorides or acetic anhydrides are replaced by this nucleophile amino group.